There are a lot of mixer modules out there for Eurorack. Small ones, big ones, stereo ones, ones with effects and sends. But one type of mixer that you almost never see done well in a Eurorack format is a matrix mixer. And an even rarer sight is one that goes beyond 4 inputs and 4 outputs while staying even remotely compact. So I decided to build one myself. This is the story of designing and manufacturing the Braid, a 5x5 stereo matrix mixer from the first sketch all the way to a finished playable module. But before we get into the build, let me quickly explain what a matrix mixer actually is and why having 5 of everything matters. Here's a simple volume control. The signal goes into the input, is attenuated and goes straight to the output. Now we can mix 2 of these level controls into one output, essentially making a 2-to-1 mixer. This will require another circuit block, which is a summing node. Let's change the layout a little bit to make it easier to read, and also let's update the mixer with 2 more inputs. What we have now is a 4-into-1 mixer, very simple stuff. Each input has a level control so we can mix volumes independently for each channel. Now, let's flip this concept on its head and make an exact negative of this concept, a multiple or a distributor. You have just one input, but 2 outputs. Each output has its own volume knob. Adding 2 more of these outputs will make a 1-into-4 distributor with level controls. Now back to our mixer. We can combine these 2 concepts, making 4 separate volume controls for each of our 4 inputs. This makes it so that each input can be routed to each output, and each output can receive signal from each input. This is called a matrix mixer, in this case a 4x4 matrix mixer. Now we can, for example, route input 1 into our output A by turning the top left volume knob. Add the third input to the mix and we have both of these inputs playing at the same time. We can also route that same input 1 to another output, like output C. Then we can add input 2 and have both input 1 and 2 going into output C. Now the mixer that I want to make adds another set of inputs and outputs, which becomes a 5x5 matrix. Pretty rare for an Eurorack module. Based on that idea, let's quickly sketch a draft of the schematic drawing we will be later making in our EDA of choice. I always try to sketch these out by hand first to make more conscious design decisions and to speed up the process later. After the schematic sketch, I move on to some rough estimates of where each input, output and controls will be to better understand how the signal will flow in physical components and to check if my initial goal of fitting the mix into a 20 HP wide module will actually be viable. I also try out different visual aids that will later make it into the panel to make the module more readable for the user. In this case, it will just be a 5x5 grid. I will go back to refining this in Figma very soon, so make sure to stay till the end to see how I make my panels. Time to finally take my ideas and make an actual project out of them. I make my designs in KiCad, which is plenty powerful for designing Eurorack modules and other simpler analog stuff. The schematic might look complicated, but it's mostly a couple circuit blocks copied a few times over. I will post the first working prototype files of this module on the Beard Instruments GitHub so that you could make a simple mixer like this yourself if you want to make your own version of it. Since it's a stereo matrix mixer, I also copied the whole circuit for the right channel. After the schematic is done, I look at my initial module layout sketch and move on to the PCB editor. Then I lay out all the components that correspond to the I/O and controls of the mixer, making sure that the minimum spacing is right so that the module is actually usable. This mostly applies to potentiometers whose knobs need to be nicely spaced out to let the user move their fingers freely between the knobs while playing. They also need to be a fair distance away from any cable inputs for the same reason. After the main parts are done, I move on to other big components like the power connector and in this case the expansion connectors, since they will dictate how my audio components will be placed afterward. It always is an iterative process. I sometimes make some slight changes even after I have started routing traces on the board. After finishing the PCB, we can finally move to the panel design. I select all the components that the user will interact with and place them onto my previously prepared panel template. That way I can just change the footprint of each component while preserving their exact locations, eliminating mistakes entirely. An SVG is then generated and inserted into an editor like Figma to make the visual part of the panel. Again, I have some templates ready that speed up the whole process and let me focus on what matters most, which are the input labels and visual cues throughout the module. I add our logo and the module name, set all whole cutout locations, and add a background that I've previously designed for this module. Then, it's another round of minor adjustments and just trying and seeing what works to guide the user through the signal path. For example, here I tried to highlight that the left input is normal to the right, when the second one is not patched in. Then I move on to creating the visual matrix pattern that the potentiometers are making, and lastly make lines that highlight each column going to its respective stereo outputs. The inputs and outputs also need clear, readable labels, which is straightforward in a module like this. I make sure to keep a visual cue of how much space the nuts take as well to keep proper spacing. The last thing to do is refining the colors and shades of grey to better match the background, and the module is essentially ready for prototyping. 2 weeks later, after ordering the PCBs, it's time for my favorite part, which is to test if the design works. For a module this size, it's fairly simple to assemble, albeit a little tedious. 25 dual gang potentiometers and 20 jacks per module is a lot of solder pins after all. I have modified the circuit to ensure the best sound quality possible, starting with better operational amplifiers and ending at custom power decoupling schemes that we have extensively tested before. On top of that, a nice little addition is that this mixer can be infinitely expandable. With minimum effort you can combine 2 of them into a 5x10 or a 10x5 matrix mixer, or 4 of them to make a 10x10 and so on. There's no need to buy any additional cables or modules, just combine your existing ones. All component choices, design iterations, simulations and testing come together in this moment. There it is, in all its glory, the 5x5 matrix mixer in just 20 HP. And that's really what this whole project has been about. Not just building another module, but building a reliable tool that I know many folks will need. One that fits into a single 20 HP slot, sounds exactly the way I want it to, and opens up routing possibilities that I genuinely haven't seen done this well in a Eurorack module before. If you've been thinking about designing your own module or piece of gear, I hope this gave you a push in the right direction. The process is iterative, sometimes tedious and occasionally frustrating, but moments like plugging it in for the first time make all of it worth it. Again, the schematic files are on the BYard Instruments GitHub if you want to build your own version. I will also do a more thorough round of testing and measure noise and distortion, which I won't be including in this video. If all our requirements will be met during that testing, the module will already be available to buy at the time you're watching this video at the link in the video description. Thanks for watching, and I'll see you in the next one.